Hello everyone. I hope you are doing good. In the previous video, I showed you some simple two exercise on linked list and recursion in one place. So I hope you got all the code written here and you knew how we got this result. If you are facing any difficulty, you can comment down, but try to understand it. We need recursion to be very clear to everyone. It may be a little bit confusing at the starting, but slowly by slowly you'll understand and it will become so easy that you can do anything in recursion and you'll start using recursion instead of using loops and all that. So it's very important. This was simple exercise, but if you understood this, it's very helpful in the later part. So today we'll be doing circular linked list. So circular linked list is one more type of linked list that is after single and double linked list. So this is just a basic code in circular linked list. Okay, I'll show you what I have written here. So I've just included this IO stream like a basic code and using space name. And if you have watched the previous video, all this code may seem familiar because it's the same code that I just copy pasted from the previous clips. So if you are new, please watch the previous videos of single and double linked list clearly because the main concept of circular linked list is directly linked with single and double linked list. Okay, let me show with the help of a figure. So this is for the single linked list. So if you haven't watched single linked list, go back there so that you understand this figure clearly. I'm saying that I already said you in single linked list, every node is divided into two parts, the data parts and the pointer parts which point to the next node. Then we came to, it had one drawback, it could not go to the previous one. So we had introduction of double linked list in which the first node could go, means every nodes have one more pointer called previous that could connect with the previous pointer. But here we could not means after the last node our linked list ended, but we could not means do repetition. We cannot iterate between all of them. So to break this drawback, we had introduction of circular linked list. What circular linked list is? Circular linked list can be done by both single and double linked list. You can see in the note is written means it is possible by both single and double linked list. Means you should have concept of single and double linked list to understand circular linked list. And the main concept of circular linked list is, okay, let me take a pen so that I can show you it more clearly. In single linked list we had a pointer that pointed to the next, and in the double linked list it had pointer both, it can point to the front or back, but it pointed here to the null in the front and here in the null, and the last one pointed to null in the next. But what if we wanted to iterate? We cannot iterate because in the last it will meet null and the loop will break. And this was overcome by circular linked list. You can see that the last one in the next, instead of pointing to null, it is pointing to the head. Means you can see it is like a circle type. It's just going in a circular loop. When it reaches the last one will point to the first node and it will just go on. In double linked list, the first one in the previous is pointing to null, but later on it will point to this one. So I hope you got the basic concept circular linked list. So let's go with the code, then you will understand in a better way. Let's go to VS Code. And now let me say what I have written here. I added a class node like in every linked list I did from the first lecture on linked list. I added a data of integer type. Then it is for single linked list, so I added only one node called next. And I added a friend class to linked list where we'll do all the functionality because these are in the private. So we need it included in friend so that we get access in the next class. So this is the next class called linked list where we'll do all the functionality. Means what will happen, what we need to display, what we need to add, all that. We added a node called head because we wanted that we should have access to the first node, then so that it become easy for us to do. You can avoid this, you can do in your own way, you can use different algo. So but try to use this because it becomes easy to understand. Then in the public, where a constructor of linked list, whenever the object is created of linked list, make this node head points to null. It's not pointing any garbage value but null, so that we don't have any garbage value in our linked list. So that is the main basic. In the int main, we create an object of linked list called node1. This is the first node. Inside this node we'll have different type of node in the list. Okay, now what is the thing we need to do? We need to add nodes and display. So let's go with adding nodes. To add nodes, we'll just write a function first, and in the function we'll add all the functionality how to add node. Today we'll be doing just adding in the front. Means we'll make everything will be added in front, adding in front. Means everything that will be entered will behave as the head. We did this in both single and double linked list. It should not be a very big problem if you have watched the previous video and have understood all the concept. If you haven't, you can just ask question. I'll try to solve it. So let's add some function. We'll write void add node, and inside the add node, we need to pass an data because we wanted it should be by the user what the data should enter. So we'll write new data, new data. Okay, now we'll write what should happen inside. Before this, we'll create one node because we want that whenever this create, we should create a new node that will be added to the list. So we'll just write node and we'll write new node equals to new, sorry, not node. Okay, now we created a new node, and inside this new node we'll pass the data. We'll just write new node data is equals to new data. I hope there's no confusion in this because I have done this more than 100 of times and you understood it in the single linked list and double linked list. If you haven't, please watch the previous video. Now we know that in circular linked list, the first node created should in the next should point to the head. So we'll just write new node next points to the head, because we want that it should be in a circular. You can see in the figure the last node should always point to the head in the next. It is a single linked list, so we are not using the previous here. Okay, I hope you are getting this. Now we'll create one more node. While I'm creating this, you'll understand the later part, but for now just create one new node called temporary node and give it access to the head. And we know that when any node have access to the head, it have access to the full list. It can access to all the nodes present in that list. So we give access to here. Now let's add some functionality if our head is null and if it is not null. For first, if our head is null, if our head is not equals to null, what should be done? If our head is not null, run a while loop in where temp next is not equals to head. We are not using here all the nullity, null means condition of null and all, because we know that in circular linked list there is no such null. This is null because the first one can be null or can add some node, but after that any node will not point to null and all that. So we are writing temp next. Why I'm writing this, you'll understand. Where let me write one more line, then you will get it very clearly. We'll write temp is equals to temp next. Okay, and come down after the while loop, come down here and just add this functionality temp next is equals to new node. Now you'll understand why we added. So we added this node and gave access to the head. After this, we ran a while loop on this temp till it reaches the head. We know that you can see in the figure when it reaches the last, after the last it will reach the head once more. So when it will reach, before reaching the head, the last one in the next, it should point to the new node just created. Means if it is not null, we know that the new node will always become the head because we are trying to add this data in the head. Okay, let me add one more line here so that you understand clearly. We'll just write head is equals to new node. This will remove all the confusion. We want that whenever new node is created, it should become the current head. So if it is current head, the last one in the next should always point to the head. I hope you got this. If our head is not null, what should happen? Now else, if our head is null, what should happen? If our head is null, just okay, let me clear out this. Sorry, I'm wasting your time, I think. Sorry for that. Okay, if it is not null, means if our head is null, what should be done? We want that this new node will become the new head. You know that whenever it is created, and in the next, this new node in the next should point to new node itself. Why is this? See, okay, let's go to the figure. Suppose there is no any node here. Suppose this was null and our new node is created. When this is created, this is the only node. So in the next, it should point to itself because we need to form a circle, and the last node should point to the first node. Since this is the last and first both, so we want that in the next it should point to itself. So the circle is formed. I hope you are getting this. So this was the main condition of adding node in the first. I hope there is no any confusion. If there is any confusion, you can just comment out. I'll try to solve it. At the end, I'll explain it one more time. You'll understand there a little bit more better. Now how to display. Before displaying, let's add some node. So we'll just write node. I hope you are doing this with me so that you don't keep it for later. So because if you do it later, you may just hesitate doing it alone. So if you are doing it now, we both are doing it the same time, and I'm doing it very slowly. I'm typing very slowly because I want that all of you should do with me so that we both can understand every line that we are writing. If I write in a speed, I can just increase the speed and all that, but I don't want that because I want that you should understand it with me so that we understand clearly. Every line is clear to all. So that is my main motto of this channel, was to make everyone understand all the basic parts so that they can do anything. They can go for competitive and all that after understanding the concept. So you can see that if you just run this, nothing is getting printed, means our every code that we wrote is in the correct form. There is no any error. Now how to display it? We know how to display. In the previous episode in single and double linked list how to display, but we can't use that. Why we can't use that? I'll show you here. Display, and we ran a while loop. We ran like while head is not equals to null, and we just printed the data. We'll just write head data, and head is equals to head next. So this was how we printed out all the data in single and double linked list, but we can't do this. Okay, we can't do this. I'll say the reason before just running it. Okay, let me add one endl. Okay, now you can see that why we can't run this, because you know head is not equals to null. Head is not equals to null means there is some node, and we know that in circular linked list all the nodes are connected to the head, means it is in a loop, it is in a circle, it's a never ending. So let me just run it so that you can understand it. Control run. Okay, there is something, an error here I think. Okay, we did not call the display function. Let's call it, okay, node1 dot display. Now if you call it, if I run it, makes laptop means my screen may crash, but you can see here what will happen. You can see this is an infinite loop. It is a while loop. It will just go until infinity. So that is the main disadvantage why we can use like we used in the previous. Okay. So you saw that it was in an infinite loop, means what we cannot use like the one we used in previous line single and double linked list. We should do some modification. So to do modification, just let's write one node. We'll write node and we'll call it temporary. Just you can name it anything. I like naming it temporaries because we're just creating it for some small purposes. Okay, we'll call it temporary and we'll give access to the head. Why I'm giving access to the head, you'll soon get it. And let's add some condition. Okay, let's go here and we'll write if head is not null. If our head is not null, then only this should run, or else don't run this. If head is not equals to null, then now there is one more concept. I told you when we learned our basic, there is one more loop that we can use, that is called do while loop. What do while loop means, it will run one condition before it checking the while condition is true or not. Okay, let's add that. I'll just cut out this line from here, and here we'll write do print out something first. Cout will print out the data that was in the temporary, because temporary has access to head. You can see a temporary has access to head, have access to all the nodes. So we'll write temp data, just print out the data and the line here, and we'll write temporary equals to temp next. I hope you got this line. So, and why we are using do while loop, because we don't want it to run infinite time, or before checking the condition we want it to run at least once. Before checking the condition means, what is the condition? Okay, let me add the condition so that you understand it better. So let me come down here and add the condition. If temp is not equals to head. I said you in this circular linked list we don't have null. So we don't have null, and that's why we cannot give a condition of nullity. Means we cannot write if head is equals to null or something is not equals to null. we can write here because our first element can be null, but our any node cannot in the next cannot point to the null, because I showed you in this figure it should always point, the last node should point to the first, and in double linked list the first one in the previous should point to the last. So there is no null, so we cannot add condition of null. So we added a new node called temporary, which we gave access to the head, and we are printing out before checking if our means why we wrote do while loop. Suppose we have only one node, that is the head node. So here the temporary and head will be the same, so this will not be executed. But if you write do while loop, this will be already executed before checking the condition. That's why we used while loop. I hope you got this. Now let's save this. Okay, we are getting an error. Why are we getting this error? This is for the if. Okay, I think everything is right. We should not get this error. Okay, now we wrote all the displaying. I hope you got the concept of displaying. Now let's display it. So there is an error. I don't know why this error is coming. Just let's run it so we know what is the error. Okay, you can see error expected at the end of input, line number 74. Okay, it's already there. Unqualified array at the end of input. Okay, I can't find what the error is. Okay, we just forgot to add one more parenthesis or curly braces because this should be for the void display. Okay, now the error is gone. Let's just clear out the console and just run it one more time. So you can see in the previous it was learning for infinite, means it was continuing on the loop, but now we got only the value that we desired, like 3 to 1. Why is 3 to 1? Because we added in the front. You can see that we added in the front, we gave access to the head. The new node should always become the head. You can do it for like adding in the AND or any random position like I did in the earlier. Just don't forget that in the next it should not point to null, and in the previous also the first should not point to null, but it should be in a circular manner, means the last node should point to the head and the head in the previous should point to the last node. I hope you got the basic concept of circular linked list. Okay, let me explain from the first so that you can understand one more time, or just take the recap. If you understood, you can just leave the video now, or who did not understand is for them. Okay, first we added this two line. This is the basics for C++. Okay, next we added a class called node. Inside the node we added some members, like we added a data, it is of integer type, and we added one more node, an instance of node called next, because we wanted that there should be a pointer which will point to the next node. And next we added to friend class the linked list, because we wanted to access these private members in this class. Okay, now in the class we added one node called the head, because we wanted to have access to the first node created. Even without adding this, you can put some other algorithm and you can do it. So we added a node because we wanted it should be simple for understanding. Next we added in the public, we added a constructor. We want that as soon as this any object of linked list is created, in the head it should be null, it should not contain any garbage value. Second, now we wanted to add node. We took here adding node in the front, means it should be head. In the head we can do it and in the random position like we did in the earlier videos, but this time we wanted to put in the head. So we named a function called add node, in which we'll pass a data, because we wanted this data to be in the integer type, this data. Okay, I hope you got this till now. Next we created a node called new node, where this is the node that will be created every time we call this function. And we created one more node called temporary node, because we wanted to add some condition in it. And in the temporary we gave access to the head, and you know that if anyone have access to the head, it can have access to all the nodes. Okay, this will be very useful in the later part, so I'm saying it now. And the new node, in the data we gave the new data that was passed in as argument in this function. Okay, I hope you got this till now. And in this line, as in circular linked list, you know that every node at the last node entered should point to the head. So you can show the figure. I'll show one more time the figure. The last node should have access to the first node, meaning in the next the last node pointer should point to the head node, and in the double linked list the head in the previous should point to the last node. I hope you are getting this. Next, okay, this is done. Now we added one condition for if our head is not null. Previously, you know that whenever this object is created, the head is null by automatic. But if our head is not null, means we already added a node. So we want this temporary node that we gave access to the head should go until it meets the head once more. Because in the next is pointing head, until it meets the head, go on, just go on. And when it reaches the last node, in the next it should point to the new node. And you know that new node in the next will point to head. I hope you are getting this. Or else, if it is null, if the head is null, what should it be done? The new node will become the head. You know that new node will become the head. You can see here, new node will become the head every time. So new node in the next should point to itself, because we want that whatever the last node is, it should point to the head. So if there is only one node, it should point to itself in the next. I hope you understood how to add node in the front. You can do it for back, and in the random position you can try it yourself. It's very easy. I already explained in a single and double linked list. So now how to display them. In the earlier videos I showed you how to display. We can just use a while loop and it will display all. But in circular linked list, I said you there is no null at the end. In the while loop we can just add a condition of nullity and will stop at null. But in circular linked list there is no sub concept. So we added one more node called temporary node and we gave access to the head. Now we wrote if our head is not null. Run this only if our head is not null. So we wrote here do while loop because we wanted if our first node is the only node, then also it should print out without checking that our temporary node is equals to head or not. I hope you got this. Now in the int main we just created a object of linked list and we pass this as the functions add node and we added 1 2 3. This 1 2 3 will be added like 3 to 1 because the last node passed will become as the new head. And next we display. I hope you got this. So you can try adding in the end or in random position by yourself. It will be a good practice for you. So that was it for circular linked list. I hope you got the basic concept, and that's how we come end to linked list. The end of linked list. The end of linked list concept, but the concept of linked list will be used in the later part also. Like when we are writing queues and stacks and all that, we'll be sometime using linked list. Okay, that doesn't mean so that you should have the clear concept of linked list. I'll upload some questions also. I'll do some exercise in the projects also. We'll do some linked list projects so that we can understand in a better way. So that was it for today. I hope you got the basic concept of circular linked list. Still, if you're facing any problem, you can just comment out. I'll try to solve all your queries. And until then, that is for today. See you in the next.